As we have learned in Section 1, tests are forms of assessments. They are administered to collect data about student learning. Test results can aid in making informed decisions to improve curriculum and instruction. Students are interested to know, what is my score in the test? In this chapter, we shall look into the types of test scores. However, the more pressing question is, what does the score mean? Hence, this chapter shall likewise present test score interpretations using norm and criterion reference interpretations. You have encountered this in Section 1. We shall now have a comprehensive discussion. But before that, test scores interpretations are vital not just for the students concerned, but also for the parents. A pupil who receives an overall score in the 60th percentile in mathematics would place the learner in the average group. The child's performance is as good or better than 60% of the students in the group. A closer look into the sub-skill scores of the pupil can help teachers and parents in identifying problem areas. For example, a child may be good in addition and subtraction, but he or she may struggling with multiplication and division. But before we start, let us read our learning objectives. At the end of the discussion, the student will be able to first, define test scores. Second, enumerate the different types of test scores. And last, cite the importance of knowing how to interpret a test scores.
Did you know that the scores we see in our tests is not just simply numbers into our scores? I just found out that there are types of test scores, and according to my sources, these results of tests are in the form of scores, which is the type of test scores, which is row scores, percentile, rank z-scores, t-scores, statinized or legal category of proficiency scores.
Oh, really, Mars? I also know the row and percentile sources.
Row and percentage score. Row score. Row score are obtained by simply counting the number of correct responses in the test. So, for example is 28 over 30 and 36 over 50. Another example is that you took a test and got 30 out of 40 items correctly. And now your row score is obviously 30. So this means you answered 75% of the test accurately. So now let's proceed to percentage score. So percentage score is useful in describing a student's performance based on a criterion. In obtaining the percentage score, all you have to do is to take the row score and divide it by the total number of items and multiply it by 100. So, example, 30 over 40. Now, our row score is 30, and let's divide it by the total numbers, which is 40, and the answer will be 0.75. So 0.75 multiplied by 100, and now we get the percentage score, which is the 75%.
And Maring answered to me before that percentile rank is. So, a percentile rank gives the percent of scores that are at or below a row or standard score. It is used to rank students in a reference sample. So, for example, a score of 35 or a standard score of 1 falls in the 84th percentile, which means the student scored as well or better than 84% of students in the sample. We could also say that students' score is in the upper 16% of the norm. If there are 200 students who took the test, a percentile rank of 84 indicates that the students scored higher than 168 students. So percentile ranks do not represent equal units. Hence, they should not be subjected to arithmetic operations. So, to calculate the percentile rank of a score, we need to follow some steps. First is sort the data set in ascending order from lowest to highest. So, you will be given a scores in which is dili sila arrange. So, you will arrange it first from lowest to highest. So, next is determine the total number of scores in the data sets. So, pila ang score na gihatag. And next, identify the position of the score within the sorted data set. So, unsa nga score imong gipangitaan og percentile rank. And next is calculate the percentile rank using the formula number of scores below the given score, divide the total number of scores, and times it to 100. So, let's go through an example to make it clearer. Suppose you have the following test scores of 75, 80, 85, 90, 95. So, it is already arranged into ascending order from lowest to highest. And we will find the percentile rank of the score 85. So first, which is to sort the scores in ascending order. So ato na siyang gi-arrange. Next is there are total of 5 scores in the data sets. Mo to si 75, 80, 85, 90, 95, which is 5. And the score we will try to find out is 85, which is in the third position within the sorted data set. So let's calculate it. So 3, which is our number of scores below the given score. So 85 is nasa ikatulo nga number sa 5 ka scores. And divide to 5, which is we have 5 scores, and times to 100. So we will get a 860. So a score of 85 has a percentile rank of 60, which means it's higher than 60% of the score in the data sets. So, that is percentile rank.
Yeah, and also the standard score is. It is truly difficult to use row score when making comparisons between groups and different tests, considering that the test may have different levels of difficulty, but in order to solve that problem, a row score may have transformed to a derived score. So, what is a derived score? So, derived score are numerical descriptions of an individual's performance in terms of norms. There are 2 types of derived scores. So, number 1 is score of relative standing, and the second is development scores. So standard score is a derived score within utilizes the normal curve to show how student performance compares with the distributions of scores above and below the arithmetic mean. The row scores above the mean have a positive standard scores while those below the mean have negative standard scores. So this score has been transformed to fit a normal curve within a mean and standard deviations that remain the same across ages.
And Mars, among the standard scores are T-scores, T-scores, and Stannan, right?
Yes, of course, but I will continue what I have shared. So this is a normal distribution and scale. The normal curve here represents a normal distribution, so as we can see, the left and the right side are symmetric to each other, so this normal curve is a symmetric theoretical distributions. The mean, which is the arithmetic average, and the median, which is the score that separates the upper and the lower 50%. The mode, which is frequent occurring score, is located at the center core because the mean and median are at the middle. It is expected that the half of the test scores are below the mean and half or above it. The mode indicates that the most scores are average level. So there is an imperial rule, which is the 68, 95 and 99.7 rule. And this rule shows the connections between the normal distributions and the standard deviation. Under this rule, 68% of the data falls with one standard deviations and 95% with two standard deviations, and also 99.7% within the standard deviations from the mean.
Mars, and the z-score?
So z-score. The z-score gives the number of standard deviations of test score above or below the x minus x mean. So the formula of z-score is z equals x minus mu over sigma, which is x is the individual value and mu is the mean and sigma is the standard deviation. And here is the z-table. This table is a mathematical table that allows us to know the percentage of values below a z-score in a standard normal distribution. To use z-table, first is go down to the row with the first two digits of your z-score. Then go across to the column with the same third digits as your z-score. And lastly is find the value of the intersection of the row and column from the previous steps.
And the latest chika I have gathered about T-score. So, T-score. Some teachers are not comfortable with using Z-scores because of negative number. For example, a score of 12 in a 20-item science test with an arithmetic average of 15 standard deviation of 2 yields a z-score of negative 1.5. That's why teachers are not comfortable using z-scores. But the student or her parents may I fully comprehend why it is negative. So it may adversely affect student motivation. To fix this, we can translate it to a percentile rank using the normal table or convert the z to a scale that does not include negative values like the t-score. So t-score refers to a specific scaling method used to transform raw scores into a standardized form. In a t-score scale, the mean, for example, in a t-score scale, the mean is set to 50 instead of 0, and the standard deviation is 10. To transform a z-score to a t-score, we will multiply the z-score by 10 and add 50. So, t is equal to 10z plus 50. So, let's calculate it. So, t is equal to 10, which is our standard deviation, and z-score which is negative 1.5. So 10 times negative 1.5 plus 50 as our mean. So 10 times negative 1.5 is equal to negative 15. So t is equal to negative 15 plus 50. So we will get a 35. A z-score of negative 1.5 converts to t-score of 35. Hence, similar to a z-score, a t-score of 35 indicates that the row score of 12 is 1.5 standard deviations below the mean. This implies that based on the test scores, the student performed below the average. The student score below the average because it's just 35 and the mean is 50.
That's right, and the stunning also.
What is stunning? Stunning is short for standard 9. It is a method of scaling scores on a 9-point scale. A row score is converted to a whole number from a low 1 to mean 5 and high 9. Stunning scores are standardized scores on each dimensions for each type. It can be used to convert any test score to a single-digit score. It calculates how much a result varies from the average or mean. In stunning score, the mean is always 5 and the standard deviation is 1.96 convert into 2. So here is the formula of the stunning score. SS equals 2 times Z plus 5. So here is the example. Z is equals to 2.5. So SS equals 2 times 2.5 plus 5. So 2 times 2.5 is equals to 5. Then bring down the 5. So 5 plus 5 is equals to 10. So your stunning score is 10.
And you know guys, we have also normal curve equivalent and developmental scores.
I know that. Can I share?
I know what you're talking about. Just leave it to me. First is normal curve equivalent. So, normal curve equivalent. It is a normalized standard score within the range 1 to 99. It has a mean of 50 and a standard deviation of 21.06. Caution should be exercised when converting a raw score to NCE because the latter requires a representative national sample. NCE is preferred by someone because it is equal interval quality. Score differences between test and among sub-tests in a test battery can be calculated and examined. For example, an NCE of 30 in reading is twice as far from the mean because our mean is 50. Like 30 plus 10 points plus 10 points before siya mo 50 mo nang in reading it is twice as far from the mean compared to NCE of 40 in mathematics, which is ihang ligas is 10 points sa mean. The student's score in mathematics was 10 points higher than in reading. Kay ang mathematics is taas paog 10 points sa reading which is 30. But both of them are still below the average score of 50, which is the mean. So the NCE score allows for easy comparison and interpretation of a student's performance related to the reference group. So another example, imagine a standardized reading comprehension test administered to a group of students. The NCE scale for this test has a mean of 50 and a standard deviation of 10. Let's say a student named Emily receives an NCE score of 60 on the reading comprehension test. This means that Emily's NCE score is 10 points above the mean. So, atong mean is 50 man. So, muna siya above og 10 points kay 60 man ang nakuhang score ni Emily. In terms of interpretation, an NCE score of 60 indicates that Emily performed better than 60% of the students in the reference group who took the same test. This means that her performance is above average compared to her peers. In summary, an NCE score of 60 for Emily on the reading comprehension test suggests that she is performed above average compared to her peers who took the same exam or test.
And the developmental score.
And the developmental score, a grade equivalent or GE, describes a learner's developmental growth. It gives a picture as to where he or she is on an achievement continuum. For example, if a second grader obtained a grade equivalent to 4.2 in language mechanics, it means his or her score is typical of a fourth grader. 2 months into instruction, note that GE is an estimate of a learner's location in the development continuum and not the grade level where he or she should be placed. Fritzling and Mayberg in 1983. One criticism against GE is that it assumes that equal learning occurs throughout the year, which is far from the truth. Further, it cannot be used to compare a student performance in the different tests or subtests. Analogs to grade equivalents are age equivalent scores. They are interpreted similarly. For instance, if a child's score in reading comprehension is equal to an age equivalent of 7.6 years, it means that the child's raw score is equal to the average score of children 7 years and 6 months in the norm group who took the test. It does not imply that the child necessarily performed at the age level of 7.5 years. Developmental scores like grade and age equivalents promote typological thinking, categorizing abilities and performance by age or grade without due consideration to variations. So, here's another example of a developmental score. Let's say a child takes an assessment in mathematical problem-solving skills. Their raw score is calculated, which represents the number of problems they answered correctly. This raw score is then compared to a norm group of children in the same age range who also took the test. If the children's raw scores is equivalent to a grade level of 5.2, it means their performance is typical of a 5th grade student. 2 months into instruction, however, it's important to note that this grade equivalent score is an estimate of children's location in the achievement continuum and does not necessarily mean they are performing at the exact level of a 5th grade student. So, a developmental score is a measurement used to assess an individual's progress and growth in various areas of development, such as cognitive, physical, social, emotional, and language skills. It provides a snapshot of their current level of development and can be obtained through assessments conducted by professionals. However, it's important to remember that developmental scores are not definitive or fixed measures and should be interpreted alongside other factors. Development is a complex and individualized progress.
Babangon tayo, susulong tayo. Babangon tayo, susulong tayo.
Magbabanat ng buto, todo-todong pagkakayon. Dahil pag may tinanim, tiyak na may aanihin. Tanim na kape ay di sa tulong nyo di susuko. At ang pagbangon natin ang gigising sa mundo. Babangon tayo, susulong tayo. Dahil ang pagbangon natin ito ang gigising sa pangarap mo. Babangon tayo, susulong tayo. Babangon tayo, susulong tayo. Babangon tayo, susulong tayo.
Babangon tayo.
Energize with Milo every day and do champ moves like James. Start your day the champion way. Be energy, energy gap. Be energy gap. Drink Milo every day. Milo every day. With your 3 balanced meals, beat energy gap. Drink Milo every day. Milo every day. Drink Milo every day and help beat energy gap like a champ.
Wow, buko!
Bagong biyak na buko, ang sarap nito, Nesfruta buko, why not?
Coconut,
Buko masarap, made with real fruit juice, Nesfruta buko, why not? Coconut, buko masustansya, rich in vitamin C, Nesfruta buko, why not? Coconut, no artificial color, real na real, kitang real, lasang real na buko, Nesfruta buko, real na real ito. Also available in mangosteen.
And those are the types of test scores. We have another chismis gathered, which is types of test scores interpretations. A frame of reference is some well-defined performance domain. Merrin and Lehman in 1985. This is needed to make sense of test scores. Scores and marks may be explained in relation to a norm or criterion. These references were conceived and differentiated by American psychologist Robert Glaser in 1963. The use of norm and criterion reference measures hinges on the purpose of assessment. For example, when assessing driving skills, the student driver's performance is checked against a set of criteria, rendering judgment whether he or she passes or fails is criterion reference. In selecting top students who will participate in an inter-school science quiz bee, the relation standing of student in a science test is necessary. Selection is made based on a norm reference scores.
Mars, we have also types on how to interpret the test scores, the norm reference interpretations and the criterion reference interpretations.
So, in norm reference interpretations, the term norm originated from the Latin word norma, which means precept or rule. By definition, it pertains to average score in a test. Apart from school average norm, There are other types of norms that can be reported: international, national, and local norm groups and special norm groups. Students who are visually impaired. So, norm reference interpretations are explained of a learner's performance in comparison with other learners of the same age or grade. A learner's knowledge is gauged in terms of his or her position in the norm group. The use of standard scores and percentile rank are common in norm reference interpretations. To say that the child placed 8 in a reading class is a norm reference description. A child's score in a reading assessment 85th percentile is another example. This means the child scored better than 85% of the student in the group. When using percentile ranks, Campbell in 1995 Quotient test interprets that percentile units are not necessarily equal in size, and it is critical importance that the norms be developed using a comparable cohort of students. So kanang ma-compare na experience at student. Cohort means is experience man. As pointed out, norm reference evaluations determine the learner's place or rank. Assessment instruments that lead itself to this kind of interpretation include standardized aptitude and achievement tests, teacher-made survey tests, interest inventories, and adjustment inventories. And according to Kubizen and Boric in 2010, a norm reference assessment tends to be general as it covers a wide scope of content measuring a variety of skills. Because there are several objectives covered, only 1 or 2 items are sampled for each learning objectives. Moreover, difficulty of test items varies and may likely result to a greater variability in test scores. This implies that scores are dispersed and scores standings become more telling. Beside the purpose of norm reference, measures it to discriminate between high and low achievers because si norm is nag-compare man muna. So, the norming process sorts and ranks students on the normal bell curve. Standardized tests are designed this way. Tests that results to norm reference interpretations often use selected response format based on national educational standards. They are commonly used for purposes like school admission, program placement, and program eligibility. Because of the ability of such tests to differentiate students, schools can determine learners who require specific educational needs. So, norm reference framework uses percentile ranks, standard scores, and stanines, and in other hand, a criterion reference framework uses percentage, speed, and precision of performance in quality ratings.
What are the guidelines in interpreting the norm reference test course? So, according from the Nitko and Brocker 2011, there are 5 guidelines on interpreting norm reference test course. The first is detect any unexpected pattern of scores. So, as teachers, we need to look out for unusual, especially the extreme scores. If the student test scores does not confirm or our observations to the particular students, then we need as teachers to reflect on our instructions. So next is determine the reason for score patterns. So we cannot deny that there are factors why the students are underperforming the subjects and any subject. Maybe it's because they have learning disabilities. If you remember the dyslexia, dysgraphia, dyscalculia, and many more, or simply they are just lack of motivation, so we need to determine that research. So the third is do not expect surprises for every student. So as a teachers, we already know and observe the pattern, the trend of their way and perform their performance on their test course. So we do not need to expect the end on that because we already know how the students perform in class. So number 4, small difference in subject score should be viewed as chance fluctuations. So the different test scores will be or may not subjects for any interventions. So example, the test scores have greater difference compared to others which have lower, but still our interventions depends if we really meet the objectives we targeted in a particular assessment or the topic that we assess. And the last one, use information from various assessment and observations to explain performance and others' assessment. So, example, it is not shocking for us teachers who already know that students is not good or poor in writing Filipino and English to have low scores in essay writing.
So, criterion reference interpretation. This word criterion came from the Greek word kriterion, which means standard. And so, criterion reference interpretations provide meaning to test scores by describing what the learner can and cannot do in light of a standard. Hence, test scores allow for absolute interpretations and not comparative, not the same as norm, which is nag-compare sila. A learner's performance is explained in relation to a predetermined criterion of mastery. Mastery tests generate criterion reference interpretations. So though teacher-made tests, skill tests, competency tests, performance assessments, and licensure examinations, multiple choice questions, alternate response items, short response, and essays usable criterion reference interpretations, since these test formats can be used to measure specific body of knowledge or skills set that students have required. However, the breadth of a content is narrow. Only a few learning objectives are covered with 3 or more test items targeting each objectives. So, Kubish, Sin, and Borish 2010. Consequently, several tests are necessary to cover a large domain of content knowledge and skills. In terms of variability, this may be minimal. What matters is the link between the test items and the criteria set forth. Unlike in norm reference interpretations, where most students are categorized as average, it is quite possible in a criterion-based test to have more students able to achieve an acceptable or high level of proficiency or otherwise. So, criterion reference scores include percentage, correct speed of performance, quality ratings, and precision of performance. Nitko and Brookhart 2011. When interpreting standardized test scores, there is an assumption of normality in the distribution of test scores. This is not necessary in criterion reference framework. When test scores are negatively squeezed to the left, there are more high scores. This implies that students perform well and speaks the quality of instruction given. However, it may also mean that the test items have been easy if positively skewed to the right. Then there are more low scores. The students perform poorly and test items have been difficult. So criterion referencing is used in diagnosing student needs and monitoring their progress. It is likewise used in certification and program evaluation. It is the preferred mode of assessment in an outcome-based education framework. The foregoing discussion revealed the differences between the two major frames of references. Despite the difference, there are also commonalities. Miller, Lin, and Grunland 2009 stated that both required specification of the achievement domain to be measured as well as relevant and representative sample of test items. They added that the same test items rules except from item difficulty are followed and the principle of validity and reliability are still observed. So in summarization, criterion reference interpretation involves assessing test scores based on a predetermined standard or criterion of mastery. While si norm is moto siya, nag-compared siya sa kanang learning sa mga student. So I will leave you with this quote. Test scores and measures of achievement tell you where a student is, but they don't tell you where a student could end up.